Hi guys, in this episode of Shri series, we're going to be talking about a concept called acceleration. So I'm going to introduce what acceleration is, then we talk about the formula used to calculate acceleration, all right? And in the next set of videos, we're going to be talking about application questions involving acceleration, all right? So how do we define acceleration? Okay, so if before I go into acceleration, let's look at a concept called speed. Now, I've put speed in various videos in Shri series, but let's look at what speed is. All right. So if we define speed, speed is simply rate of change of distance. All right. So if I was to convert that definition into a formula, that would be speed is d over t, all right? Because one, you've got distance, so there's a small d, and then rate of change, all right? So the word rate means time, all right? Therefore, speed is distance over time, okay? Now, let's visit another concept called velocity. All right, so I'm just going to rub this and talk about velocity. So, if we were to define what velocity is, it's rate of change of displacement. All right, so the formula for velocity therefore becomes V, all right, is displacement over time. Now, different textbooks have different ways, changing ways of abbreviating displacement. Some books go like V is equal to S over T, where that S is your displacement, all right? However, for the sake of you being familiar, I like to put DISP over time to say that's displacement, all right? Now, if you look at the definitions, distance and displacement, from the eyes of a layman, it may sound the same thing, but you got to remember that displacement is different from distance, all right? Distance, as you know, is the length between 2 points, whereas displacement is the length between the start to the end, all right? So for this sake, you got to remember that when we look at acceleration, we look at a concept called velocity, all right? So we've defined what speed is, we've defined what velocity is, we've looked at how distance and displacement are different. Let's visit acceleration, which was the purpose of my lesson today, all right? So what is acceleration? So acceleration is change in velocity over time, all right? Another definition would be rate of change in velocity. You can see how I've done a small tweak, which is instead of putting over time, which I did in the first statement, in the second one, instead of putting over time, I put rate of change. All right. So acceleration is either change in velocity over time or rate of change in velocity. Okay. Now, it's important that we understand the word definition because that will guide us into showing you the formula to represent acceleration. All right, so keep these two definitions in mind, and we're now going to write down the formula to calculate acceleration. All right, so just remember, acceleration is change in velocity over time or rate of change of velocity or rate of change of velocity over time. All right, so let's call acceleration. All right, that's the formula. Now, because we've got a change in velocity, all right, there has to be a difference in velocity. Okay, so let's look at the initial and final. So to calculate acceleration, the numerator is change in velocity. So, like I said, we put change in velocity over time. Now, let's get into the technicalities. All right, so let's put acceleration as small a, and change in velocity is delta v. All right, so the word delta means change. So delta v means change in velocity over time. All right, so let's say a is equal to delta v over time. What is delta v? All right, for example, we talk about change in temperature. If we want to find out the change in temperature, it's technically the initial temperature, final temperature, subtract final minus initial, and you get your change in temperature. Likewise, in velocity, you've got your initial velocity, you've got your final velocity, you subtract, you're going to get the change in velocity. All right, so delta V now becomes final velocity, or vel, so just for abbreviation, we'll put vel for velocity minus initial vel over time. All right, so that change in velocity over time is final velocity minus initial velocity over time. All right, now there's different books that give different abbreviations for final and initial. All right, so let's simplify this. A becomes final velocity is v minus u as initial velocity over t. And that, folks, is the formula used to calculate acceleration. I wanted to spend a bit more time in this because I could have simply written down the formula and just ended this video. But physics is about understanding the concepts and knowing why are we using these concepts. All right, so you can see from the formula v minus u over t, the fact that it's v minus u, that tells you it's a change in velocity. And then over time means rate of change in velocity or change in velocity over time. All right, so if I was to put an abbreviation, the small a stands for acceleration, v stands for final velocity, u stands for initial velocity, and t stands for time. All right, now I want to show you what is the unit used to calculate acceleration. So let's work through this. Final velocity is meters per second, initial velocity is meters per second, and time is second. So before I tell you what the actual formula is, I want you guys to think. All right, so we've got a final velocity over, minus initial velocity. So the unit is meters per second. So that's meters per second. Divide by time, which is s. So when you get meters per second divided by second, what is the formula? A now becomes meters per second, or you can say meters per second squared. Therefore, folks, the unit of acceleration is meters per second squared. All right, like I said, I could have jumped straight and told you the formula for acceleration, but I wanted you to understand how we obtain meters per second squared, because physics is not about memorizing, it's about giving a rationale, what it is, and how do we conclude that the unit for acceleration is meters per second squared. All right, so in summary, acceleration is change in velocity over time, or rate of change in velocity. The fact that you've got change in velocity, you've got final velocity minus initial velocity over time, or a is equal to v minus u over t, and the unit to calculate acceleration is meters per second squared. All right, in the next set of videos, we're going to be talking about word problems involving acceleration. Thanks for listening, guys. Bye now.